All right, well, good afternoon, everybody. This is Randy Alper with the California Air Resources Board. I'm glad you're able to make it here today. Hopefully you'll get some good information. This class is a little bit different than the ones we would normally be giving, as we don't tend to talk so much about regulation in this class. We talk about equipment. That's why it's called the Diesel Particulate Filter, or DPF, Operation and Maintenance class. This is a shortened version of a longer class that we used to teach here at the Air Resources Board. This one is going to be somewhere in the 2 to 2.5 hour range. And the information is, there will be some regulatory information, but for the most part, I'm going to be talking about what these things are and how they work. So before I can get started, I do have to give you a little bit of administrative information. Number one, we do have another person online with us today. That's a co-staff, co-teacher of mine. Her name is Katie. Katie, do you want to say hi to everybody?
Yeah, good afternoon, everyone.
All right, fantastic. There's Katie is serving a amazingly important function in that since I'm going to be presenting the material, she's going to be monitoring the questions dialog box during this presentation. So what that means for you is if you have a question, because the webinar has all the attendees muted, you will not be able to yell the question out. That's not the way this normally works. What we do is we ask you to write your question in the question dialog box. And to that end, I would appreciate if somebody could respond on the dialog box that the audio is coming through. So if you can hear me right now, please say something. And, oh, there we go. All right, somebody said something, so we've got the audio working just fine. All right, so the second administrative thing that you need to be aware of is that this is being recorded. I don't mean you're being recorded. I mean the presentation is being recorded in a slideshow format, so it'll look exactly the way you're going to see it with my voice overlaid. And that is something that you do have access to after we're done with the presentation. This is going through GoToWebinar, and they have a storage site where after every presentation, a recording will be downloaded from my system to their system, and it will be available probably a couple of hours after the presentation is over. If you would like a copy of that, then please send either Katie or I an email, and we will get that to you as quickly as we can. I just noticed something that Katie, I don't know if you can help me with this, but I didn't put the handout up. So if you can find that and upload that, I'll let them know where it's going to be. So the Katie hopefully is going to be putting the handout also uploaded to the dialog box on the right-hand side of the screen. You can see right below the questions box is a handout. Right now it says 0 of 5. When we get done putting that up there, it'll say 1 of 5. It'll be a PDF format. You can download it at any point during the presentation. Once the presentation is over, the handout will not be available anymore. That's not to say I can't send it to you. It's not to say that Katie can't send it to you. It's just that you won't be able to get it automatically because you're in the webinar. If you wind up not being able to download it, we have had that problem where periodically somebody will try to download it from the handouts portion of the GoToWebinar software and not be able to. So whatever the case may be, if you need the handout and you can't get it while we're here today, just let one of us know and we'll make sure we send that to you. All right, so let me get through the actual outline. So the very first thing I'm going to do is talk just a little bit about regulation. I'm going to get into basics and try and help you understand where the requirements for filtration systems have come from. And then I'm going to get into the meat and potatoes of this actual class. I want to talk about what these filtration systems are and how they work. I'm going to tell you right now that I've been doing this for more than 30 years. And when I first started working with the Air Resources Board down in El Monte, there was nobody in my line of business or my line of work that thought we were ever going to be able to get a diesel particulate filter to work to the level that they work right now. So it's amazing and it's fantastic. These things work, but there are some things you need to know about them. Most people don't know how they work. So I'm going to go through that. And then I'm going to talk about the 2010 engine and something called SCR. SCR is short for Selective Catalytic Reduction. It is the component of the air pollution control system that was required or came on the 2010 and newer model year engine. So we'll talk about what that is and how that works in conjunction with the filtration systems. Once I get past that, you'll have all the information you need to understand how these things work, hopefully. The last part of the class talks about two different things. It talks about how choosing a filter for a particular engine is done, and more importantly than that, it talks about how to maintain these things. I think personally this is the biggest disconnect that I see between the regulatory side of agencies like mine and the regulated public, where we're mandating things to happen, the feds are mandating things to happen, and the mandate in this case requires these filtration systems. The individuals who own the trucks with these systems on there, or the individuals who purchase filters to put on their trucks, are doing something because they have to, and they don't really understand what that is actually going to mean to them as far as the maintenance of their truck and the maintenance of the filter. So I spend a little bit of time at the end of this class talking about some of the problems that filtration systems have and what different maintenance issues there are associated with it, and what some of the tools are that you can use or relay to people that have these filtration systems to help them understand that maintenance is one of the key things when it comes to taking care of a filter that's on one of these trucks. So for regulatory part of this, it all started, well, it started before 1998. Up to 1998, the Air Resources Board knew that particulate matter was an issue. We had identified several different pollutants called criteria pollutants. Actually, federal EPA designated those as criteria air pollutants, but the Air Resources Board had been doing work trying to identify the sources of these pollutants, what the impacts were, and how to regulate the emissions of these criteria air pollutants. From 1970 all the way until 1998, even though we did speciate the particulate matter into size, we really did not differentiate between standard particulate matter and particulate matter coming from, say, a diesel engine. In the 90s, we started to find we started to acquire data that gave a different story to us. It basically said that we needed to focus, as far as the impact of a particular substance on a physical being, we needed to focus more on the pollutants, the particulates that are coming from these diesel engines. And some of the data was just unbelievable. We found that up to 70% of the known cancer risk identified from air pollution could be somehow linked to the pollution the particulate matter coming from diesel engines. So in 1990, I think actually we're going to go through all of these. In 1998, the Air Resources Board, in conjunction with the Office of Environmental Health Hazard Assessment and something called the Scientific Review Panel, all came to a conclusion that this diesel particulate matter was something we needed to handle. And the Air Resources Board had the last word on that. We identified diesel particulate matter as a toxic airborne contaminant. Now, what that means is, if you're into federal lingo, it's nearly the same thing as a hazardous air pollutant. So the feds call them HAPs, we call them TACs. Now, our process was a little bit more lengthy than what the feds did. They just simply adopted a list of hazardous air pollutants, and eventually we did as well. But this is one that wasn't always on the federal list. What a TAC means is that it causes some type of mortality or serious illness, and it's hazardous to human health. Even the WHO identified diesel PM as carcinogenic, and this designation led to something called the risk reduction plan. Now, the risk reduction plan is something that the Air Resources Board adopts. It's a document that the Air Resources Board adopts after we have identified something as a toxic airborne contaminant. This is a document that is researched and put together by staff, and it has two main goals, or parts, if you will. The first is to set goals. The goals in this particular diesel risk reduction plan were to reduce the levels of diesel particulate matter in our air based from 1990 levels by a total of 75% by the year 2010, and an additional 10% reduction by the year 2020. Now, we passed both those dates. We're in 2020, so we've already passed the beginning of it, and we certainly passed 2010. Do you think we actually made those levels? Did we reduce diesel particulate matter by 75% by the year 2010? Have we done it for the 85% number for 2020? Well, I can honestly say that we did make it for 2010. We had actually a little bit more than a 75% reduction in diesel particulate matter by that date. I will say that it wasn't necessarily all because of our regulation. It happens that right before or in the midst of this program that we were putting out there, we also had one of the worst economic downturns this country has ever seen. And in the state of California, there were millions upon millions of diesel operated equipment that were parked and not running. So even though we did have stronger regulations and we might have made that number anyway, I think we were helped along by the fact that that all this equipment was parked. Now, nobody wants, the economy to go sour because of something like that. But in the case of meeting this goal, that was potentially a reason why it happened. Now, did we meet the 85%? Nobody really knows. We're looking at the data right now. We have a research division at our agency that pours through the information that is collected on air monitoring sites, does comparisons, cleans up the data, does all kinds of work trying to make sure that when they present the data, that it is accurate and they can truly say that we met that goal. I don't believe we're going to know whether we met that reduction until sometime next year. That was the first half of this reduction plan. The second half is a strategy. Okay, we've got goals. How are we going to meet these goals? Well, in this case, the plan called for doing three things. It called for making the engines cleaner. So stricter engine standards, more stringent engine standards. Now, one thing that some of you in the audience probably know, but if you don't, I'm going to inform you right now that when it comes to new engines, even though the Air Resources Board has an engine certification program, we don't have the legal authority to certify engines in such a way that the manufacturers can only meet our requirements. All new engines are certified by federal EPA. We work with federal EPA and we do run a concurrent certification program, but the authority to certify engines for sale in the United States rests with federal EPA. So that's more of a federal program. The second component or strategy was to reduce sulfur in diesel fuel. I told you a few minutes ago that I've been doing this for over 30 years, and I can distinctly remember when I was working down in the El Monte area that we would take samples or get samples of diesel fuel from a variety of locations throughout the state, and it was not uncommon to have a diesel sulfur content somewhere between 10,000 parts per million all the way up to 50 or even 100,000 parts per million. It was a natural component to the getting the oil out of the ground thing. Some oil that just had more sulfur. In fact, if you know the oil market, you might have heard something called sweet crude. That is a crude that comes from certain parts of the world where sulfur is not a big deal. So it's cleaner in that sense. In any case, what is the issue with sulfur? Why do we need to get rid of this material? Well, sulfur has a lot of good qualities, but when it comes to combustion, it has nearly only bad qualities for our purposes. High sulfur content in diesel fuel does two things. Number one, it doesn't burn very well, and anything that doesn't burn very well that's in the fuel is going to turn into particulate matter. So the more sulfur you have in diesel fuel, the higher the particulate load coming from that engine. So automatically, if we want to reduce the particulate matter load, we want to reduce sulfur to get there. The second reason why sulfur is a problem in diesel fuel is that sulfur has a tendency to poison catalysts. And a lot of the technology that is being used and implemented to make the engines run cleaner, or at least clean the exhaust after the engine has produced the exhaust, uses catalysts. So if we get the sulfur out of the diesel fuel, we succeed in two ways. We reduce the particulate load and we protect the catalysts that are also reducing the emissions or helping to change the emissions at least. All right, so those are both nationwide. So we reduce sulfur content requirements here in California to no more than 15 parts per million. That was very soon adopted by the feds as well. So right now, today, and for some time, you should not be able to manufacture, buy, store, sell, or transport any diesel fuel anywhere in the United States that has a higher sulfur content than 15 parts per million. The last strategy that's listed here is regulation to reduce emissions. So that is where the Air Resources Board comes into its own. We have put out more regulation to reduce diesel particulate matter than any other agency in the world. And I think we've done a fantastic job of categorizing different sources, and then regulating them to the point where the content of the emissions have been low enough so that we can probably meet these goals. The new engine certification, let's talk a little bit more about that, because that's where the, I don't know if it's the rubber meets the road, but it's where the engines come from. So when an engine is certified by federal EPA, the Air Resources Board gives that engine something called an executive order, or EO. We issued it based on the certification standards from the federal documents. Now, it is certified by engine family, and you may have heard that particular phrase before, but an engine family, what that means is that there may be 2, 3, 4, or a dozen or more different engines that all fit into a same family for certification purposes, because they're similar in how they function, the components that they have, and the emission rates that they produce. They aren't different enough that we would call them a different engine. They're not identical, but they are very close to the same type of engine. So these engines are all certified to these families, and it has happened in the past that the feds, I said earlier that the feds have the authority to certify all new engines, and they do. There was a point at which California, regulatory-wise, the Air Resources Board took control over engines that were allowed to be certified for California use. And we were mandating that the manufacturers produce engines that were cleaner than what the federal standards stated they had to be. Now, that created a problem where the manufacturers, some of them, would produce engines that were basically cleaner than anywhere else that the feds said they had to be. So they were good in all 50 states because they were already cleaner than what the feds required. But the manufacturers also produced engines that did not meet California standards, and they would not be something that could be registered for use in the state of California, or not even sold in the state of California. Those were called 49 state vehicles. And that problem was something that ultimately got the federal EPA to take over the control and do exactly what I said a minute ago, where they basically said, California, you can't force manufacturers to produce separate engines for California. Now, on these executive orders, they include a lot of information that is important for you to know where it is and how to get it. They will have the family name associated with each of these engines and the engine families. They'll give you the emission standards associated with the engine, as well as the controls that are used to get to those emission standards. They'll provide the models and the power ratings as well. Here's the example of the top of one of ARB's executive orders. You can see the number on the far top right-hand side. You can see it's a new on-road heavy-duty engine, and this is manufactured by Cummins. Now, if you get past the language, you can see that this is a model year 2007 engine. It's 6.7 liters. There's the family name, and you can also tell the fuel type is diesel, so we're looking at a diesel engine. And the intended service class MHDD is medium heavy duty diesel. Now, on the far right-hand side in the middle there, you can see ECS and special features. Now, ECS stands for Emission Control Systems. This is where you get an acronym listing of all the components that were put on this engine designed to control the emissions of that engine. So those acronyms will be outlined in the document further below, but just to give you an idea what some of these things mean. The DDI stands for direct diesel injection. ECM is electronic control module, that's the brain. TC is turbocharger. Charge air cooler is a system that works with a turbocharger. EGR is exhaust gas recirculation. OC stands for oxidation catalyst. And the last one is one that you might want to look for if you are looking for an engine that has a pre-installed filter from the factory. That acronym actually stands for periodic trap oxidizer. And if I were to see this executive order or the engine plate and see that acronym, I would know that this engine came from the factory with a filtration system, because that's what it is. You can get some of the same information from the engine tag itself. Now, this is what's called an emission control label. When the federal government certifies new engines for sale in the United States, one of the things that they require manufacturers to do is to place a label with the certification information somewhere on the engine itself. This label will have all the information related to the model year of the engine family, the standards that it meets, and a whole lot of air pollution related information. In fact, you can see in the language down there, it says this engine conforms to 2000 US EPA and California regulations for large non-road compression ignition engines. So from that phrase alone, let me tell you what you can figure out. First, it's a 2000 model year engine. Second, this is an off-road engine because it says non-road. There's a little bit of a vernacular issue between the states and the feds. Earlier, I told you we say TAC, they say HAP. Well, the feds use the phrase non-road or off-highway when they're describing what we call an off-road. So when I look at that, I see off-road. That's an off-road engine. If I didn't have that information, though, I could still get the same information or pretty much the same information by just looking at the engine family name. And that is on the top right-hand side. You can see there that it's YPKXL 03.9 AK1. That family name has all the information that I need to know what this engine is. The first letter is always designated in a standardized family name. The first letter is always designated as the model year. So Y, if you go look at EPA's list, will be for the year 2000. PKX, the next 3 digits, are always going to designate the manufacturer of that engine. So Perkins Engines, if they manufacture an engine, if that company does, all their family names are going to say PKX in the next 3 digits. The 5th character is something of interest if you want to know what service class this engine is made for. That's where you'll find this information in that 5th character. L is actually the single most common letter that you'll have associated with off-highway, off-road, non-road. And then the next 4 digits, 03.9, some of you are already way ahead of me on that. That is the displacement of this engine. So that gives you the size of the engine itself. In this case, that decimal point happens to be one of the characters that we count as a family name or as part of the family name. And this is a 4-liter engine. AK1, the last 3 digits, are where the manufacturer has some flexibility to designate this particular engine class. That is their designation for this engine. Here's another one from Caterpillar, and you can see the same kind of information. On the top right-hand side, you can see it says to 2008. When you look in the language in the middle bottom kind of thing, it also says 2008 model year, so we know this is a 2008 engine. If we look at the family name, 8CPX H0928E1X, 8 is the first letter, so that's the model year, 2008. CPX is the 3-letter designation for Caterpillar. H is the 5th character, and the last one was an L. L is generally off-highway, off-road. H happens to be on-highway, so this is an on-highway truck. Now, Caterpillar decided not to use liters. They decided to go with cubic centimeters. So 0928, 928 cubic centimeters. So that's their choice, but they can do it. You might even see some that are listed in cubic inches if they're a little older. And of course, E1X is their 3-letter designation code for that particular engine. You can also see the same acronyms that I showed you on the executive order for this engine. It goes through, and the engine tag is going to list those as well, like it does here. But what do you really need to remember about this? Well, the engine family name, what is it? Well, it's found on the emission control label, and it represents the name associated with a group of engines that all have similar characteristics and similar emissions. What I'd like you to remember from that name is, what is the engine service class? Is this an off-road engine or an on-road engine? The reason I want you to remember that is because when it comes to regulation, say the truck and bus rule or the off-road diesel vehicle regulation, we don't care how you use the piece of equipment, generally speaking. We care how the engine was certified. So if an engine was certified to an off-road standard, we regulate it as an off-road engine, regardless of how you use it. And the same is true of on-road. The next thing I'd like you to remember is, does this thing have an OEM filter? OEM stands for original equipment manufacturer, and all that means is that it was built that way from the factory. So for on-road, any 2007 or 2007 or newer is typically going to have a filter installed from the factory. For off-road, it could be Tier 4 final. All Tier 4 finals should have a filter, and many Tier 4 interims will have a filter. Let's get into some of the other components that have caused some issue with people understanding these certification standards. And one of the biggest issues that people have had over time has been something related to a program called Aftermarket parts. So here's the deal. People do a lot of things when they work on their engines. Sometimes they do them because they have to. Let's say a component breaks on the engine, it needs to be replaced. Sometimes they do it because they want to install something snazzy like that chrome header and all the exhaust pipes that you see in the picture right there. Either way, what they're doing is taking a piece of the engine as it was certified off and replacing it with another piece. Now, in California state law, the vehicle code specifically stipulates, and Federal Clean Air Act prohibits it as well, modifying the engine in any way from the way it was certified. So legally, technically, federally and California, you are not allowed to remove any component of that engine from its original certified components unless it is an exact duplicate. Now, you may think that's not a big deal, but most engine manufacturers do not support the manufacture of engine components much more than about 5 years after an engine has been built and sold. So a 2015 engine, say, will start losing the ability to buy new parts from the factory that are exact duplicates this year.
Randy, we have a question.
Sure.
What if they claim the modifications are 49 state compliant, but have never submitted data to prove that? And then how does that affect federal regulations?
I'm not sure I understand the question completely. If they took something off the engine that was 50 state compliant and they are modifying it to make it 49 state compliant, is that what you're saying? Because so here, I'm going to answer that question because I think that's what they're saying. If an engine is certified by the feds with components on it, you're not allowed to change those components at all. You're not allowed to rejigger the certification. You can't take it from a 50 state certification to a 49 certification legally. If that's what they're going at, that's the answer I have. If they have another question related to that, Katie, obviously stop me again.
Yeah, I think that was covering it. Also, Randy, just as an FYI, the handout for this particular presentation is not on the shared drive, so I can't upload it. I don't know if you want to just pop it up before we finish up, like during our question period, and then people can have access to it.
Yeah, I probably will have to do that because I think I remember now that I was modifying it and it might be on my personal drive. So
yeah.
Okay, I'll try and do that before we get going, before we finish.
And we do have one more question. I wanted to get a little more information from the person before I asked you, but they have a pretty specific instance. So they're trying to install a DPF on an off-road loader that has an opacity reading currently of 27%. And this is for port as well, so cargo handling. The standard is 40% or lower on the engines. DCL refuses to sell the filter because they want a reading of 20% to install it. Their question is, if they're unable to find an under the hood, not an external DPF, are they still CARB compliant so long as the opacity reading remains under 40%, or do they need to purchase a DPF if it's already compliant with the opacity?
Because that was a long question.
Yeah.
Did you say off-road earlier?
It's off-road loader, and it's at a port, so cargo handling.
Okay. Yeah, so they do have a PSIP requirement.
Yes.
Well, first of all, the PSIP requirements have been modified for on-road. I'm not sure where we're going, but I believe we're going to be going to the harbors modify as well. And 40% is no longer going to be legal for engines that were getting it before. If you can't get a filter to be installed on one of those to lower the particulate levels coming from the engine, it's going to be difficult to get it to pass the PSIP regulation. PSIP, for those who don't know what I'm saying, is Periodic Smoke Inspection Program. It's a requirement for on-road diesel vehicles as well as harbor craft, where you test the vehicles every year, and you're basically blowing smoke and measuring how much smoke comes out. So the level of smoke, the more smoke you get, the higher the level is. And the current, I believe, the current requirement for harbors is still 40 and 55% based on the engine model year. I could be wrong about that.
I think it was updated in 2011. I'm looking at the FAQ, which I'll post into the question dialog box as well, just in case people are curious. And Lauren, I'll send it specifically to you. But it looks like it's based on the grams per brake horsepower hour certification, and it goes from 55 to 5% based on that. So kind of an interesting one.
Yeah, so we're gonna have to dig into that a little bit more, because that's more specific question than I really can get to right now. Let me get into the aftermarket parts where I was headed before and see if we can go a little further with this. I was talking about the fact that when you modify an engine in any way that was built a certain way from the factory, that actually breaks federal and state law. However, there's a problem there, because if you have an engine that the manufacturer doesn't produce exact duplicate parts for any longer, you have no choice but to buy parts and install parts that don't exactly match what the requirement was. So that's why in California we passed something called a aftermarket parts exemption. And this is a section of the vehicle code which essentially exempts you from having to comply with the first part of the vehicle code, where it says you can't put anything but an exact duplicate. It allows you to put aftermarket parts. And the one key phrase that's in there is that you can put parts on as long as they do no damage to the emission. They're substantially the same, but they don't hurt the emissions of the engine as it was certified. Now, why is that important? Let me get to this here. Well, first of all, let me show you what one looks like. Here's an executive order for an aftermarket part. Anytime a manufacturer wants to, so when I'm gonna go back one slide just to point this out. You see that chrome header that's up in the picture right there? That was not something that you'll have come on any regular vehicle. That is something that you can buy to soup a vehicle up. And it is considered a component that might affect the emissions. So if you were just to buy one and put it on and not worry about it having any kind of certification that it does no damage to the emissions, and you went to go do any kind of smog related thing, smog check, you would be failed even without measuring the emissions coming from your engine, because that particular component is not certified to do no damage to the emissions. So component manufacturers are required, if they want to sell parts for vehicle engines in California, they're required to get these executive orders for each of the parts that they want to put for sale. The executive order will have a number associated with it. It'll tell you precisely what the device is, what it works on, and it will allow somebody to legally purchase this device and replace a component on an existing engine without doing any damage to the emissions. The problem is a couple-fold. Number one, the same manufacturer will produce a correct aftermarket part as they will produce one that doesn't have to have an aftermarket part exemption. So they're selling parts, the same part out of state as they sell in California, but they've certified one version of it for California and the rest are not certified for California. But when the internet came about, you can buy anything from anybody and have it shipped here without any problem. So we've got a whole bunch of components that do not have these certifications that are being sold and installed on vehicle engines in California that technically are illegal. That's problem number one. And by the way, if you've never gone and taken your vehicle, if you've ever souped up an engine, I know that not everybody does that, but if you ever know somebody or have done that yourself, and you took it in to get a smog inspection, the most smog inspectors in the state of California would not touch it unless you gave them the paperwork that said these components had that executive order certification. Otherwise, they could lose their license. So that's problem number one. But related to diesel particulate filters, there's another issue with this aftermarket parts exemption. Aftermarket parts exemptions are not difficult to get. And there are a number of nefarious actors who will create a device that they say reduces the emissions of engines, and they will, maybe it does, they will get an aftermarket parts exemption because it at least doesn't do any damage to the emission. And they will sell that device as a replacement for a filtration system because they have this ARB certification. So it's kind of a buyer beware. If you're in the market for a filtration system, make sure that the executive order does not show that it's an aftermarket part. And an aftermarket part will have D in front of the name, the executive order. It'll say aftermarket parts on it, but it will also say executive order D-something-6. This is not a replacement for a diesel particulate filter. This is just something that does no damage to the emissions. So be a little careful with that. There's an example right here. Now, Bosshard isn't actually, that engineering company is not actually in business anymore. They went belly up a couple, 3 years ago, but for a while, they were in the process of getting one of their filtration systems certified certified by ARB, verified is the right word actually, to be a diesel particulate filter, but they hadn't quite got there yet, and they wanted to start selling these devices. So they got an aftermarket parts exemption. You can see there, CARB EO number D-690. That's an aftermarket part. And even though this filter technically did reduce the emissions to the level that it was required to for being a diesel particulate filter, because they weren't currently verified, they legally could not sell it as a replacement for a filtration system. They were pre-selling these devices. I don't think that worked out very well for them, but in any case, it's something that the labels have to be labeled. I mean, the filters have to be labeled with as well. If you want to get a filter, now I realize many of you in this audience probably are not in the market to buy a diesel particulate filter, but I'm taking you through the process. The diesel emission control strategy, which is a device that is installed, as I said a few minutes ago, on engines that control diesel emissions. In order for that to work as a retrofit, it has to go through a verification process. So these diesel particulate filters that are being installed in some cases across fleets to comply with emission standards that ARB is setting up, they have to be verified as an actual verified diesel emission control strategy, which puts them in a different class than an aftermarket part. It puts them in a class where they technically have proven that they meet the emission reduction requirements that are required by law. Now, this quantifies the system's performance. We verify these systems for particulate matter and NOx reduction. It's verified based on what engines and tiers of engines that it can go on, and it's unique for each engine type. So you typically will not have a verified diesel emission control strategy that works on both an on-road engine or an off-road engine, or even one that works on either of those and a stationary engine. So this system is supposed to ensure that the technology, if they claim that it reduces emissions, there's proof that it does. It also provides some warranty for anyone that purchases one of these devices and puts it on their engine. It is something that is different than the aftermarket parts exemption, and that's why I try and go through this explanation. There are some warranty periods that you have to be aware of that are required by ARB and the feds for manufacturers in producing emission control systems. So for emission control systems for on-road, you can see that the warranties go anywhere from 2 years to 5 years, and anywhere from 60,000 miles up to unlimited miles. And that's for a filtration system that has been given a verification. For off-road, similar kind of thing. Now, this is an executive order for a verified diesel emission control strategy or a filtration system. And other than the language on the page itself, you can see that the executive order number starts with DE rather than just a simple D. So again, if you happen to be in the market or know somebody in the market for a retrofit filter, it is in your best interest to do some homework. Find the executive order for the devices that you're being sold and ensure that you're getting something that has actually been verified to function with your particular use, your particular engine, and will provide the right emission reduction. Let's talk about the family name associated with these particular devices. So diesel emission control strategies, verified diesel emission control strategies, filtration systems, have their own separate family name. It's similar in construction to the family names that we talked about for the engines, but it is different enough that I need to explain. So on a diesel emission control strategy, you will have a plate that lists the family name with these components. It'll say what state it's verified in, it'll say who the manufacturer was, the year it was verified, if it reduces particulate matter, what level it will reduce, and there's only 3 choices there. It's either 1, 2, or 3, and I'll go over what those are in a little bit. It'll also put in a percentage if there's any NOx reduction and tell you what the application is. So for example, if it says ST, that's for a stationary engine, ON, on-road, OF, off-road. And then the very last thing, similar to the engine family name, there'll be a listing for the alphanumeric code that's issued by the executive order. Here's an example of a pure filter device and the family name at the very top, CAECS 2003 PM3 N00 on DPF02. So it was made, it was verified in California. The company was Emission Control Systems. It was verified in 2003. It's a PM level 3 filter, so that's the highest level there is. This particular filter has no NOx reduction associated with it. It was certified to an on-road standard, so it should only be installed on on-road engines, and their number is DPF02. Interestingly enough, you'll also see, this is for a retrofit on a filtration, that is a filtration system. You'll see that plate on there, but you'll also see a flow diagram. That's because we had people who were putting these things in backwards, sometimes purposely, and it was causing some problems with particulate emissions. So when our enforcement officers are out in the field and they see a retrofit, they will look to make sure that that arrow is pointed in the actual flow of the exhaust that the engine is producing. Here's another example of an engine label. So legally, if you install a retrofit, it has to have its own label, and there has to be a comparable label with the same information installed somewhere on the engine itself. That's what you're looking at here. This one happens to be for a device and a company that are no longer in existence, but still it's an example of what it is. If you have an OEM, so any 2007 or newer model year engine, which came with filters from the factory, they don't need this. They don't need it here, and they don't need it on the filter itself, because those will be listed on the emission control label. So these DECS, these labels I'm talking about right here, are only designed to be worked on retrofits. All right, so what I keep saying retrofit, I keep saying diesel particulate filter. I've gone through the regulation. Let's talk about how these things work. We'll be talking about the particulate controls, something called a wall flow filter, how they're constructed, and how they actually operate. First things first, I've mentioned this a few times, the levels of filters. So as with most technology, diesel particulate filters actually went through stages of development. And we started with something that has been around for a long time, something called a diesel oxidation catalyst, which is identical in many ways to the catalytic converter that you all have on your regular gasoline vehicle. If you've ever seen the inside of these things, people describe them as honeycomb. That's why I put the picture up there that looks like a honeycomb. What it is each of those honeycomb openings is a channel that goes from one end of the device to the other. There is no physical block stopping any of the exhaust from going through those channels. The purpose of those channels is to allow for the impregnation of catalytic materials coating the inside of those channels, which actually produce oxidation that would not happen at the temperatures you would normally have the operation of the engine producing. So as the particulates and hydrocarbons, now particulate matter is nothing more than solid hydrocarbon. As hydrocarbons go through these devices, the hydrocarbons will react in the presence of a catalyst, and they will be oxidized. They will be oxidized to mainly carbon dioxide, water, and nitrogen gas. So the level ones were the easiest, simplest first go at it. And the reason we don't really use those so much anymore when it comes to diesel particulate matter is because of the level of control that they have. A level 1 diesel particulate filter is only capable of controlling somewhere between 25 and 49% of the soot coming from the engine. That's not enough. That's not enough. We need to have more control than that. So then level 2s, somebody came up with this device, and this is still considered a flow-through filter, which similar to the level 1, there's nothing that physically blocks the exhaust gases from going through this. However, it's constructed a little bit differently. Instead of having just holes or channels, it's packed with wire mesh. And if in your mind's eye, I want you to picture something. Picture a canister, a cylinder that is just stuffed with steel wool. Now, if you can picture that, imagine the air or the exhaust going through that. Now, there isn't physically anything that prevents the exhaust from going to one end or the other. The exhaust can go around all the wires. However, because the wires are packed in there and they're all squiggly and all over the place, the exhaust gas has to make turns right, left, up, down, forward, backward. And as it does this, the particulate matter loses energy and it deposits itself inside the filter at a higher rate than it would if it were going through a simple diesel oxidation catalyst. These filters can remove anywhere from 50 to 84% of all the diesel soot that comes from the engine. Now, that's still not enough. I know it sounds like a lot, but it's still not enough. Remember, this is a toxic airborne contaminant, so we want 100% control if we can get it. So that's where a level 3 diesel particulate device comes from. This is called a wall flow filter, and if you were to look at its construction, it would be very similar to the level 1 device in that it has a series of channels. The channel walls are all made of ceramic material. They make them out of ceramic because ceramic can take high heat and these things get hot. The biggest difference is that there are two differences. One, on each end of this channel, there's going to be a plug. Well, one plug on each channel. It'll either be on the intake side or the exhaust side. If a channel is plugged on the intake side, on one side of the device, it will be open on the other side of the device. If it's open on the intake side, it will be plugged on the exhaust side. That's difference number one. Now, these plugs are impermeable, by the way. Difference number two is that the ceramic material that the sidewalls are made of has been treated much like you would treat activated carbon. You can see a picture, a blown up picture of it right there in the middle right hand side. It looks kind of like a sponge. They aerate this stuff as it's cooling so that it has millions upon millions of tiny little channels and holes, which are only big enough to allow exhaust gas to pass through. Anything solid is going to get trapped inside those holes. So what happens is the exhaust gases go into the open channels with the particulate matter. The gases themselves pass through the sidewalls and go out the other end of the device, while the particulate matter cannot, and it can't go through the plug at the end, so it gets trapped inside the chamber. That does create a problem because ultimately that will collect to the point where the soot overwhelms the ability of the filter to collect anymore. Here's a little bit more of a blow up. You can see what's happening. I see the air coming in, you can see the plugs, you can see the exhaust gases going through, and you can see the particulate matter being deposited inside the channel itself. Now, what do we do with this particulate matter? Because when it gets to a certain point, it will plug the filter and it will prevent airflow from the engine. And I'm not supposing that anybody in this audience happens to be a mechanic of any kind. But if you really wanted to understand how engines work, especially diesel engines, they're much like air pumps or lungs. They breathe in and they breathe out. If you were to stop the breathe out part, what do you think would happen? Well, the engine would not be able to breathe in. The lung would not be able to breathe in. It can only breathe in to a certain point before it has to exhale or get rid of that exhaust. So when you do that, when you place something that is plugged in that process, you choke the engine. Engines that have plugged filters will lose power. They'll start to derate. They'll start to chug. they will have major issues, whether it's an OEM or a retrofit. So we need to get rid of that soot somehow. The soot accumulates and it has to be taken care of. It has to be gotten out. Now, the process of getting rid of the soot is called regeneration. And regeneration is nothing more than the combustion of the carbon particles. Now, carbon, if I can draw another mind's eye picture here. Imagine taking a handful of this raw carbon and crushing it into a cube. What you're making is a chunk of charcoal. Now, how do we get rid of charcoal? Well, we burn it. We burn it. We create a chemical process called fire that actually converts the solid carbon particulates into gaseous materials in the process of burning. That is how we regenerate this filter's ability to actually remove all of the soot. Now, these processes, this regeneration process, can happen in several different ways, and that's really what differentiates filtration systems from one another. The basic problem we have here, though, is that carbon requires a specific minimum temperature in order to combust. If you have nothing but oxygen, let's say we just had a bunch of chunks of charcoal and we put it in a Weber or some crucible that we can burn it, we would have to get that charcoal up to 1,000 degrees before it would actually stably burn on its own. Now, why is that a problem? Because most engines cannot get to 1,000 degrees in the exhaust. If they did, they would mostly burn up. So that's not going to be doable for most engine duty cycles. In fact, it's very few that will get to that temperature. So what do we have that we can get the temperature of combustion down? Well, the first choice might be a fuel-borne catalyst. We tried these. This is adding something to the fuel, a catalytic material that actually is able to cause the reaction of the carbon soot particles to happen at a lower level. In this case, it's at 850 degrees instead of 1,000, that's good. It's almost a 25% reduction, but still you're looking at engines that really don't get to that temperature often, if at all. So we need smaller numbers. We need a temperature that is lower, and that's where another catalytic reaction comes into play, and it's called NO2. NO2 is nitrogen dioxide. And in the presence of nitrogen dioxide, carbon particulates will actually burn at 480 degrees Fahrenheit. Now, that is still a little high for some engines and the operation of many engines, but that is doable. So we need somehow to get nitrogen dioxide produced in the exhaust or available in the exhaust to be there for the combustion of the particulate matter. That's when we start talking about the kind of filter and the regeneration strategies. A passive system will be able to burn the soot without having any additional energy added to it. It uses the duty cycle of the engine and the temperatures produced by the engine to passively burn the soot off. That would be the NO2. An active system is one that doesn't produce any NO2. It's not using catalysts. So we need to add energy to that one. Now that energy could be added in a number of ways, and I'll show you those in just a second. The final choice is something called a hybrid system, which might have some passive component as well as some active components. So it has a little bit of both going on. Let's explore these. Before we need to talk about duty cycles. So I keep using that phrase, and I want to talk to you about what that means. So the diagram or graph that you see here in front of you shows the engine temperature of an engine as it's used throughout the day. You can see at the very beginning when the engine is turned on, we're at a very low level of temperature because the engine is running. It's just started, so it's still cold. At 200 degrees Fahrenheit, that's not hot enough to do any soot burning at all. As the vehicle is used, the temperature rises. At some point, it goes above or hovers around the 480 mark. We know that if we have NO2, we can actually burn off some soot right there at that point. And then we go throughout the day. If you can see where it drops back down around 200, either the engine was turned off or we're in an idle state there. And then we keep fluctuating up and down. Looking at that graph, You can see that the parts above 480 might be when the truck or the vehicle is on a freeway operating at a high rate of speed. The parts where it's below might be where it's stop and go traffic. This is a duty cycle, a temperature range duty cycle for a typical vehicle. As long as we're at or above that 480 number, it is useful and capable of using a passive type regeneration system, because at or above that 480, you're burning the soot off as it's being produced or faster than it's being produced. When you're below the 480, you're collecting soot faster than it can be burned off. So you're actually loading the filter. These passive regeneration systems are able to get by just using the exhaust gas stream. The NO2 oxidizes the soot around that 480-degree mark, but the problem is we need to generate, or we need to somehow have that NO2 available. That's why these systems will almost always use a diesel oxidation catalyst. So I know some of you in the audience are saying, wait a minute, I've heard this before. What is a diesel oxidation catalyst? I went over that a few minutes ago when I was talking about the level of DPFs. Diesel oxidation catalyst is a level 1. So almost all OEM filtration systems and many retrofits will have a component that is a diesel oxidation catalyst built into them. They may also have a catalyzed filter component as well. See, the manufacturers were putting things together to see what actually worked. In this example, we need to create the NO2 that is necessary for the regeneration cycle. The DOC, you can see on the left-hand side in the example, you've got the engine, you've got the filtration system, and you can see the DOC is at the very entry point of all the exhaust. So as the exhaust goes through it, you're going to be burning or regenerating or oxidizing somewhere between 24 and 49% of all the soot that's coming through. As you oxidize that material, you're doing a couple of things. You're creating heat, and you're also taking the nitrogen oxide that is being produced by the engine and converting it almost entirely to NO2. Diesel engines produce a lot of NOx. NOx is either nitrogen oxide or nitrogen dioxide. If you were to take a look at the amounts of each of those produced by a diesel engine, the nitrogen oxide is somewhere around 70 to 80% of all the NO coming from the engine, and that rest of it is NO2. We need it to be exactly the opposite. We need a 70 to 80 to 90% NO2. So that's where the DOC comes into play. Now, in the second-hand diagram you've got there, you've got the same engine, you've got the same filter, except we don't have a DOC. What's happened here is that we've put catalyzed material on the actual collection parts of the filter itself, and it accomplishes the same goal. As the exhaust comes in, it'll contact or make contact with the catalyst part of the filter. The NO will be converted to NO2, the heat will be produced, and the soot will be oxidized all in one place. All right, so the diesel oxidation catalyst, just a little bit more of an explanation. It is a level 1 diesel particulate filter, uses precious metals, typically platinum, palladium, rhodium, and it uses oxygen and NO2 to promote the oxidation of a variety of substances coming from the engine. Here's an example of a Johnson Matthey CRT. CRT stands for continuous, I'm going to lose this one. Continuous regeneration, I'll remember it in a minute. You can see the inlet, that's where the exhaust comes in. The very first thing that it hits is something called the diffuser, and the purpose of the diffuser is just to spread the emissions out so that they don't all deposit on one part of the next component. The next component is the diesel oxidation catalyst, which again does two things. It burns some of the soot, produces or changes a lot of the NO to NO2, and it raises the temperature. And then you have the wall flow filter where the rest of the reaction and collection take place. Active regeneration is quite a bit different than the one I've just talked about. In this case, we don't have the production of NO2. We do not have the duty cycle necessary to produce the temperatures for that to work. So we have to add the energy. Now, the energy being added can be done in a number of ways. We can use actual burning of fuel. That will do it. We could use an electrical heater, but whatever we use, we have to get the soot up to the 1,000-degree temperature. Otherwise, this regeneration just doesn't happen. So active electrical heaters are much like the old stoves. I don't know if any of you still have one of these. My parents used to have one of these. So that little resistor coil that you see is actually the same exact kind of thing that you would see on a stovetop with that kind of resistor. Its function is to produce enough heat to burn the soot off of a filter. Now, it requires electricity, and you cannot, in my understanding, I don't know of any system that's actually capable of doing this. It's difficult to impossible to produce enough electricity to make one of these work on a vehicle that is actually in transit running on road. The battery systems and the generator systems that on-road engines or off-road engines have just do not produce enough electricity for this to work right. So this unit or type of unit will almost always have to be plugged in. It has to be plugged into shore power so that there's enough electricity to make this thing work. You can see here where a transit bus is parked right next to a plug where the unit is actually plugged in, and it's getting power in the right voltage and wattage and amperage in order to make that system burn off the soot. So the kind of duty cycle that one of those buses have is exactly what I was saying is a problem for burning of soot. This would be one that's stop and go, local city traffic, doesn't pick up a lot of speeds, it's just going from one block to the next. So those type of systems are almost always producing more soot than they reduce. This particular one is made by Donaldson. That blue box you see there is the electrical, what do they call those? It converts the incoming electricity to the right voltage and amperage to work this unit.
So Randy, we also got a question about emergency backup generators, and this would be another situation where you could use this kind of regeneration, because a lot of times when they do their exercises, they're only running for 10 to 15 minutes unless it's a load test. So the person that asked the question pointed out the engines typically don't get hot enough in that scenario to regenerate. So that is a case where you could use active regeneration.
Yeah, you might have to, actually. Whether you use plug-in or not is another story. This is just one choice. We've also got a portable system that works to do the same exact thing that other one did, except it's one that can go and be moved around, but still it requires shore power or electricity from the grid in order to function properly. The other choices involve active fuel dosing. So these come in a couple of different flavors. One of the more expensive but more robust systems out there uses something called a fuel burner, where it actually taps into the existing fuel system for the vehicle and ignites that fuel inside the filtration system itself. You can see a picture of that on the bottom right-hand side of the slide. It uses a blower to bring in fresh air so that combustion stays stable, and it burns across the filter, creating enough temperature for that to happen. The second type of active fuel dosing system uses catalytic combustion, where it taps into the vehicle's fuel system, but instead of having an actual burner, it uses a catalytic material. And you can see right here an example where the filtration system is loading, then some fuel is sprayed into the exhaust. It goes through a diesel oxidation catalyst. And diesel oxidation catalyst, we keep mentioning that phrase, it doesn't care where the hydrocarbon comes from. If it comes in contact with hydrocarbon, it's going to try and oxidize that hydrocarbon, which means it's going to produce heat. So raw fuel is raw hydrocarbon. You dose the exhaust with that, it goes over the diesel oxidation catalyst, creates the heat, which then burns off the soot. So this is one that you'll see in a lot of OEM systems. And it could be a fuel dosing unit in the exhaust. It could also equally be just a different event in the entire injection process. If you want to get into engine technology, there's a whole bunch that goes on there. but that's another fuel dosing choice. So what are the differences between these two systems, the passive and active? Well, the passive system, as we went over, it uses the temperatures that the engine creates. It doesn't need any outside energy. Active systems do. Passive systems are dependent upon the use of the vehicle. That means they require a specific duty cycle in order to function properly. Active systems don't really care, what the duty cycle is. They're going to be able to produce the temperatures necessary regardless. Passive systems always use catalysts and nearly always use a diesel oxidation catalyst. Active systems use different components depending on the manufacturer. We went over a couple of them. And just to give you an idea, there's probably more than 40 or 50 different filtration configurations, whether they're OEM or retrofit. I'm just giving you the basics. Now, the third choice that I went over when I first mentioned passive and active is something called hybrid. And I don't know if I mentioned it before, but I'll say it again. Hybrid systems are always what you're going to see on an OEM filtration system. So all on-road engines and Tier 4 final and most Tier 4 interim that have filtration systems installed at the factory are going to be hybrid systems. The reason for that is because the manufacturer has no idea how these engines are going to be used. They don't know what the duty cycles are, so they have to create a system that can function either way. And in this case, you're looking at a system that has a burner and it also has a catalyst. The red filtration media designates catalysts. Let's take a look at a few of these. First one would be this system here, which you can see that red rectangle. We already saw this before. This is a diesel oxidation catalyst. So is this active or passive? That DOC was in a passive system. And this one regenerates by allowing that DOC to do two things. It burns off some of the soot to create temperature, but it also creates or modifies the nitrous oxide coming from the engine into nitrogen dioxide, so that can be used in the secondary reaction to burn off the rest of the soot in the filter media. This system right here is exactly the same. You saw this before as well, except the DOC is built into the filter media. So this is a passive system and regenerates using the same functionality that I just went over with the DOC system. This one just has a flame. So there's no catalyst at all in this system. What we're looking at here is totally active. This would be the most common manufacturer for this kind of device is a Hoos. That's a manufacturer that makes a device that uses a flame and some of the fuel from the vehicle to create that flame. So that's where the temperature is coming from. This one, if you know your engineering and electrical diagrams, you can see there's a plug-in right there with a switch. And you can see the squiggly lines there. That represents heating element. So in this case, we've got an active system that uses electric heat to generate, or electricity to generate heat to burn off the soot. And here you've got the hybrid system. So we've got a flame and we've got the red filter media. So that means there's catalyst there. So we use catalyst when it's available. We catalyze when there's enough heat to do so. But we also have the ability to bring in the flame for those times when temperatures in the duty cycle just do not generate the appropriate level of heat. We also have a hybrid system here. You've got a plug-in electric and you've got the catalyzed filter. All right, so that's how filters work, basically. Let's talk about 2010 engines for just a minute here, because this has been a confusing thing for a lot of people to understand exactly what is a 2010 engine. So on the far left of this diagram, you have an engine. It's producing exhaust. You can see the exhaust particulates come out of the engine, and their first thing that they're going to go into is going to be a diesel particulate filter. Now that particulate filter is one of the types like I just went over. It removes 99.9% of the soot coming from that diesel engine, but one thing it does not remove is the oxides of nitrogen. Even though we used the NO2 as a catalyst to reduce the particulate matter, when you use the NO2, it actually converts back to NO. So we still have a NOx issue. And that's the second pollutant that we try and control with these diesel engines. So there's heavy amounts of NOx in the engine. In a 2010 engine, that would go through a secondary system. You can see that in blue right here, the blue cylinder on the bottom. Now, that system is very special. It has a filter or catalytic bed that looks identical to the one you have in your catalyst, your catalyst for your regular vehicle. The difference is that it is coated with a special material that will only activate and reduce NOx when it's in the presence of pure ammonia. Now, ammonia is an extremely dangerous substance. We cannot ask people to put pure ammonia on their vehicles because when they get into accidents, the ammonia would create a tremendous hazard for any cleanup or anybody that is around that accident. So we cannot do that, but we still need ammonia in order for this device to work. So that's where something called DEF or diesel exhaust fluid comes in. Diesel exhaust fluid is in the tank right above the SCR system. And in the exhaust between the diesel particulate filter and that selective catalytic reduction system is an injection point where some of this DEF is injected into the exhaust. Now, DEF fluid is actually urea, and urea is a high nitrogen component or chemical that when you expose it to the right temperature of heat, it actually converts nearly 100% to ammonia. So as long as we inject that into the exhaust where the temperature is the right temperature, it will convert the urea into ammonia, and then the ammonia can be used in the selective catalytic reduction system to get rid of the NOx. Now what it does is it uses NH3, which is ammonia, and it reacts with the NOx, the nitrogen oxide and whatever nitrogen dioxide is left, and it produces water and nitrogen gas, both of which are copiously in copious amounts in our atmosphere. So that's the 2010 engine. A lot of people confuse the idea that the filtration system and the SCR system are connected somehow. They are not. They're different systems, completely different systems. They do completely different things in completely different ways. They just happen to be on the same engine. So when I hear people say the DEF fluid is going into the filter, it drives me nuts because it does not go into the filter. It's specifically for the SCR system. The basics of the SCR system are shown here. You can see the DEF tank again. You can see the exhaust coming through. It goes into the catalyst with the DEF that has been converted to ammonia and comes out nitrogen gas, and mainly nitrogen gas and water. There will always be some CO2 because we've combusted the carbon as well. The reaction looks like this. There's on the bottom, I only put this one in there so you could actually see the reaction on the bottom. It's nitrogen oxide plus nitrogen dioxide plus 2 ammonia going to 2 nitrogen gas plus 3 water. There are some issues with this system that you should be aware of. It is sensitive to contamination and plugging. The SCR catalyst is easier to poison than a lot of catalysts. If the temperature is not right, the SCR systems operate in a very narrowly defined temperature zone. So when the temperature is not high enough or too high, it actually causes something called ammonia slip, and that is where the ammonia does not get consumed in the SCR catalyst reaction, and it's able just to go straight through and out the exhaust. Oftentimes you'll know this is happening because you will smell really stinky ammonia type smell around some vehicles that are having some problems. You also have a problem when the filtration systems go through a regeneration. The temperature, the 2 times when it's a problem is number 1 during startup when the engine's not warm enough to create the temperatures necessary. And the second part is when the filtration system is going through a regeneration, because what happens when it goes through a regeneration? It increases the temperature of the exhaust. It's burning the soot off. So it may drive this catalyst, this SCR system, to go into a slip where it's releasing ammonia because it's raised the temperature of the exhaust too high. All right, now we've talked about the devices and how they work and what they are. How do we choose one for my engine, the right device for my engine? Well, we've got lots of help for you there. We've got web pages, and we've got compatibility checks, and we've got installer checks. So let's talk about the DECS install page. There's the address right there. If you go on there and you click diesel activities from the ARB homepage, and then click diesel exhaust retrofits, you can link to this page. It's also linked from the site we have called Truck Stop under Help and Resources, and select it where it says PM filter information. The install page is going to give you program background like I already have. It'll give you an overview of some installations with some videos that we have there. Some of those videos are a little dated, but the information in them is still very good, so I would encourage you to go take a look at that. We will have lists of approved, manufacturer-approved installers for filtration systems, along with maintenance guidelines, some advisories and FAQs, and a list of all the currently verified systems that are available for all engines that we know of. This is the current DECS install page, and I've pointed out how to find and install DPFs. If I click on that link, it's going to take me here. Now this one we have a database. It's actually a search engine that you can plug in your information about your particular engine, and it will give you a listing of those filters that actually are verified to work with your particular engine. If you just want to look at all the currently verified devices, there's a link there, and it's going to take you to this page, which shows a listing of all the level 3 PM filters, what kind of filter system it is. For example, you could see one that says just straight DPF, so it's just a diesel particulate filter. That would be just a filter bed. There's the carrier EES that has a DOC. You can see that it's listed there. This system also lists the amount of PM that's reduced by each of these, as well as any NOx reduction associated with these devices. And then finally, the applicability, what kind of engines you can actually put these on. The first one, the Bossart, even though I said they're no longer a business, you can see that they had a filter that was able to be installed on every on-road engine that runs diesel that had a 93 through 2006. That's a very broad application. A lot of times you didn't see those kind of applications available for some of these devices. I also wanted to point out the fact that there is a clear information page. I've drawn an arrow right there. I don't know how many of you in the audience ever were involved in the long mile issue associated with a company called Clear, but that was a debacle from, well, it's been about 8 years ago now, but in any case, we do have some information there, and hopefully you've been taken care of if you did have that problem. Okay, wait. Did I go too far? No, okay. All right, so this is the database that I was talking about, the searchable database. You can get there off the same page, and again, you punch in if you want to search by emission control system, by executive order, by engine family. You can browse by the model year, manufacturer, and displacement of your engines, and it'll give you a list on the verified list of the components that will actually work as retrofits. Before you do the retrofit, you do need to do a compatibility check with the engine. And this is an assessment to determine whether or not the engine will actually accept a filter properly, and whether the manufacturer of the filter will actually allow you to install it on that engine. The compatibility check is going to do several things. The first thing it's going to look for is the opacity. Now, we talked about opacity earlier. There was a question related to that, but again, opacity is nothing more than a measurement of the density of smoke coming from an engine. The higher the density of smoke coming from the engine, the higher the opacity will be, and the more soot that's coming out of that engine that will need to be collected and controlled. For on-road engines, there are, to my knowledge, no manufacturers that are going to sell you a filter if you produce more than 10% opacity, uncontrolled opacity. Most engines are much less than that, especially if they're well taken care of. So there's a pre-installation checklist that has to be filled out as of October 1st, a couple of years ago. And the opacity will tell you a lot of things. It'll tell you if there's problems with the system and your fuel injection. your turbocharger, if you're burning too much oil, or if the engine just needs a tune-up. The executive order on the filtration is going to list the specific requirements necessary to install and operate any of these filters. It'll give you a listing of the family names, the model year range of engines, as I said earlier, the minimum duty cycle requirements, whether it's passive or active. If there's technology on the engine that will cause problems, sometimes an EGR system will actually negate the ability to use several different filters. Many filters, says currently none here, but since I put this together, there are several filters now that will not offer you a warranty if you put fuel additives in your system. And a lot of systems will not allow you to install a filter or maintain a warranty on a filter if you use biodiesel or very ultra low or a diesel that has too much sulfur. Now, data logging is something that can be required. It's only required if, for a retrofit installation if you think you're going to install a passive system. And the reasoning behind that is the manufacturers want to make sure that their passive system will work with your duty cycles. So they require you to do this data logging. And data logging is nothing more than the installation of a device that measures the temperature of the exhaust during normal operation at the point where the filter is going to be installed. So here's a whole data logger right here. You can see the device where it's installed in the exhaust right there. It has a wire that's plugged into that little computer system. There's the computer system, there's the plug in the exhaust, and there's the plug that goes to the computer system. That whole little device there will generate a graph like this. And this is exhaust inlet temperature trace, which means that it's a measurement of the exhaust temperatures over time. The time stamps are along the bottom. The temperature stamps are actually the spikes of the chart itself. You go through this, and then the manufacturer is also going to look at this data, which will show you a histogram of those inlet temperatures. And from this one, I don't know if you can see this. It's hard for me to see this as well, but you're getting up to a temperature range very early that would easily fit into many filtration systems. Even toward the end, you might get a little, but there's a lot of down there low temperatures in the middle use of this duty cycle. That could create problems when the manufacturer analyzes the data as to whether or not they decide to sell you a filter for this particular duty cycle. But let's say you've done this, or you decide to install an active system so you don't have to do that. In either case, you're ready to buy a filter. You need to have someone install it that knows what they're doing. So the installers have to be approved. This is not done by the Air Resources Board. This is done by the manufacturer. Only the manufacturer can approve an installer because they're the ones that have gone to the manufacturer's classes to understand how to do the installations. The list of approved installers, we have several different links on our website that show this. I think I actually have it here. It says how to find and install DPF. If you click on that, you go to find an installer, and it's going to bring up 3 lists. There are installers that are approved for on-road applications, off-road applications, and transport refrigeration unit applications. Now, those lists on our website are updated, I want to say every quarter, but if I were you and you had a question, I would probably call the manufacturer that you're interested in and see if they have a more current list of approved installers. All right, so now you've had this thing installed, or you have an OEM one. What are you going to do to make sure this filter stays working? Well, you're going to maintain the thing. And this involves not just maintaining the filter, but also making sure you maintain the engine. So let's talk about both of those. The engine maintenance is key because an improperly maintained engine is going to produce more particulate matter, and that is going to clog the filter in a quicker manner than an engine that is properly maintained. This involves several things. Number one, making sure that you keep the engine's configuration. You worry about that you pay attention to how the engine's operating. So let's go through those. Not changing the engine's original certification configuration. What that means, and this goes back to the aftermarket parts discussion that I had earlier, is you really don't want to be adding components that are going to change the emission parameters, because that's going to change how the filtration system functions. It's going to change how it reacts and how it's able to keep up or not keep up with the particulate matter being produced by the engine. You also don't want to mess with injection timing, turbocharger settings, or fuel pressure settings. These are all things that a good quality mechanic can do almost with their eyes closed, but they're also things that are going to change the way the system was designed. And ultimately, that's going to change the way the filtration system is capable of functioning. Beyond modifying the engine's original equipment system, you also need to pay attention to how the system is functioning. So for overfueling or under airing, I don't know if I can say this enough, but unburnt fuel equals particulate matter. I think I said that early on. I'll say it again. Unburnt fuel equals particulate matter. Where do we get unburnt fuel? Well, in the case of diesel engines, because they're running a compression ignition cycle, which that's another whole class right there. If you have more fuel than is necessary for the combustion process because of a clogged injector or leaking injector or some kind of defective turbocharger or leak in the coolant system, you're going to have problems with too much raw fuel getting through the combustion process in the form of particulate matter, and that will overwhelm the system. Under airing is the same kind of thing, it just comes from a different place. This would be, for example, if you had a clogged air filter. So if you have a clogged air filter, maybe your injection system is fine, maybe you don't have any leaks, maybe the turbocharger is fine, but your air filter is clogged, and so it's not allowing enough air into the engine to take care of the amount of fuel that's coming in. So you're going to have the same issue. You're going to have more soot being produced because you haven't taken care of the air filter. And that is going to wind up causing problems with the filtration system. There is one way you can determine how an engine is functioning without taking it apart. Now, good mechanics will be able to tell you what an engine is doing, but a lot of times historically, mechanics have used the emissions, the exhaust, to actually make the call as to what could possibly be going wrong. So when an engine puts out blue smoke, for example, generally you're burning oil. When an engine puts out white smoke, generally you're probably burning coolant. The mechanics are very good at seeing those things and determining what's wrong with the engine. The problem with filtration systems, however, is that they're going to remove these indicators. The filtration systems are there to remove soot or particulate matter. Well, burning of too much oil or burning of anything which would produce particulate matter that the mechanic can use to diagnose is going to disappear because the filter is taking it out. So how do you find out what's going on with an engine? Well, one method that I think is probably one of the best, and it's not that difficult, is to do what's called an oil test. Now, you can do this when you're changing the oil, so it happens regularly, or you can do it whenever you need to. But all you really have to do is to take a sample of the oil and take it to either a lab that you want to have tested or go to a dealership and have them do the sample for you and test the sample. They will send you back a report, looks like the one you just see there, an oil analysis report, that will give you information on what's in the oil itself. Now, why is that important? Well, because if you're burning water or coolant, antifreeze, that's going to show up in the oil. Those leaks are going to show up in the oil. If you have too much wear in the turbocharger, the oil is lubricating the turbocharger, so it's going to wind up taking minor deposits from the metal that the turbocharger is made of, and that's going to show up in an oil analysis. So these oil analysis can give you an idea, sometimes up to 6 months in advance, of when something is ready to break in that engine. It'll certainly tell you when something is causing a problem with the emissions or the engine operation. So I mentioned oil sample because one of the biggest issues with filtration systems failing is engines that burn too much oil. This could be overconsumption of lube oil, hydraulic injector oil, turbocharger oil, valve guides are worn out, piston rings are worn out. All these things can cause too much oil consumption. So the only way you're really going to be able to figure out if this is an issue is to monitor your oil consumption. Don't add, this says don't add oil to the fuel tank. That's kind of crazy, but you may not believe this, but some of the older engine manuals actually said to do that as a way to get rid of old engine oil or old engine oil. In any case, monitoring your oil consumption closely so you know when it's burning a little bit of oil versus a lot of oil. And some of you in the audience might be thinking, well, my engine doesn't burn oil. Well, you don't know engines, because all engines are actually designed to burn oil. I don't want to get into a long discussion about how engines function, but most of you probably are aware that there are pistons in an engine. These pistons is where the combustion process takes place, and they go up and down, and that's what turns the engine. In order for a piston to go up and down, the cylinder that it's in has to be lubricated properly. And because of the way they're built and because of the way they function, there's always a microfilm of oil that gets combusted every single time an engine is turned on. It's just a matter of how much. It's a matter of how much. The more an engine is worn, the more engine oil it's going to actually burn. So all engines burn oil. It's normal. When you get a filter installed, whether it's OEM or retrofit, one of the things that you want to make sure you use, because most OEM filter manufacturers and practically all retrofit filter manufacturers require you to use an oil called CJ4, which is particularly designed to reduce the level of ash accumulation in the actual filter itself. And I need to explain that because of what we're talking about here. So when you collect soot in a filtration system, that is raw carbon that's coming from the engine. But that is not the only thing that comes from the engine that gets collected by the filter. Let me see if I get the ash can come from a lot of different places. It can come from engine wear. It can come from burning the oil. There are components to the oil that are heavy metal in some cases, and when the filter goes through regeneration, all the carbon is burned off, but anything that is non-combustible isn't burned off, and it will stay in the filter until the filter gets overwhelmed by the amount of this ash material. It can also come from where you operate the truck. So one of the things that I talk about in a couple different classes I have are trucks that are used a fair amount on dirt roads or on construction sites, because the dust that is produced on those areas will oftentimes make its way past the air intake system and into the combustion process. Dust can be made up of combustible materials, but it's also a fair amount of rock and silicates, and those don't burn at the temperatures that we're regenerating these filtration systems at. So as a consequence of working in those dusty areas and going through regeneration, we're going to have a buildup of the dirt material, although it's burned, but it's still part of that. So we need to be aware of the fact that that's something that can build up inside these filtration systems and periodically has to be cleaned out. By periodically cleaned out, I mean every truck that has a diesel particulate filter, whether it's a retrofit or OEM, every once in a while, the owner of that device has to take it to a shop that cleans filters, and they have to take the core out and clean it using devices that are recommended by the manufacturer to get the ash out. How often you do this depends on how much ash you collect. Not all filters are cleaned the same way. Some of them use air pressure, some of them use temperature, some of them use water. I know it says water will destroy a filter, but I just recently looked at a device that uses saponification, which is soapy water, to clean filters. That and sound waves to actually get the ash out, collect it, then they super dry it and make sure that the filter is operational again. These are all methods to clean the filters. Here are a couple of devices that you can put the filters in to have the ash removed. Now, the one on the left is actually particular to a manufacturer that's made by Donaldson. they recommend that you use their device to clean their filters. However, they will also allow their filters to be cleaned by other devices as long as they use a mechanism that doesn't destroy the filter media. And the unit on the right is one that's commonly allowed by many different filter manufacturers. It uses a vacuum system as well as an air knife and sometimes temperature in order to get a maximum of ash out of these units. The ash cleaning intervals are going to depend upon you. You know, could be once a year. Most manufacturers, if you read the executive orders, it's going to say every year or until necessary or as necessary. That could be every 2,000 operating hours. It could be every 50,000 miles. The one that I prefer is to use how much oil is consumed. So if I'm using a low ash oil, the CJ4, then when my engine burns 24 quarts of oil, and I know that sounds like a lot, but diesel engines burn more oil than normal engines, then my filter is probably full of ash. And it's probably time for me to have it taken somewhere and cleaned out. That gives you, this chart actually gives you an example. It's a bar graph. Example of the comparison between standard oil and CJ4 oil. If you have standard oil that doesn't have the low ash component to it, you only get 16 quarts burned before you have to clean the filter out, while the low ash CJ4 will allow you to burn 24 quarts of oil before it has to be cleaned out. Once that ash is cleaned out, regardless of whether it's you that's doing it, if you have one of the devices necessary, or if more likely you take it someplace and have it cleared out, that ash in the state of California is supposed to be treated as a hazardous material. Now, it may not be. If it was tested to prove that it's not, then it doesn't have to be treated as anything other than ash and can be disposed of in the regular garbage. Most people won't do that because it costs more money to test these things than it does to actually dispose of them as a hazardous material. But if you're in the market for somebody to remove and clean out the ash from your filtration media, make sure you get a copy of their logs and what they do with the waste. Otherwise, you could at some point be pulled in if there's a disposal issue. I do have to talk about something called component swapping, because this is something that that happens with some people, whether you're talking OEM or retrofit filters. You know, when the filter's clogged, you can't use the vehicle until the filter's cleaned out. So some people will keep an extra filter handy, filter core, to drop in, and while they have the other core cleaned out. As long as there is a component swapping agreement from the manufacturer of the filter, whether it's OEM or retrofit, that is perfectly acceptable to do. It's not something that happens every day, but it is something that can be done. It will be listed on the verified, the page where we have all the verification for each of these devices. Can I remove an old filter and put it in another truck? I've had this question a number of times in the past, where somebody says they own a couple different trucks. They paid a lot of money to put a filter on one of their trucks, and that truck got in an accident which creamed the truck, but the filter is fine, and they don't want to lose the money on the filter, so they would like to take it out and put it on the other truck. Well, there is a way to do that. It's called redesignation. You want to make sure that the manufacturer of the filter has a redesignation agreement on file with the Air Resources Board, and that you own both the truck that was wrecked and the new truck, because otherwise it doesn't, it's not allowed. You can see the swapping and redesignation agreements here on this particular filter on the far right hand side. That's going to be a PDF that tells you what actually is allowed. Now we've talked about how to take care of a filter, and we've talked about ash clean out, and we've talked about what the filter is. But there's another topic I want to make sure I cover, and that's how the filter lets you know, and the system that it's part of lets you know what condition it's in. And these would be indicator lights that all filter systems come with. Okay, hold on, why is it doing this? Oh, froze, I must have. Okay, so you look at this one right here, and you've got a retrofit. I know this is a retrofit because the warning light system right there actually is like a Radio Shack special. These warning light systems are there to tell you the status of the system. Is it okay? Does it need regeneration? Do you need to regenerate as quickly as possible? It's connected to the filter. Let's see if it comes up here. Come on. All right. It's connected to the filter using those two plugs. One of those is measuring the temperature across the filter, and one of them is measuring the pressure across the filter. Now, the pressure is measured because the higher the pressure differential gets on one of these, the more plugged it is, and the more it needs to be regenerated. The temperature is measured because you need to make sure it achieves the right temperature for regeneration to be successful. So both those things are important, and both those things will be monitored and relayed back to the driver of this device. If it's a retrofit, it's going to be installed in the dash like this one or the one I just showed you. This is a little blow up of the one I just showed you installed. You might have simple ones, you might have complicated ones. This is a very simple one right here. If you're driving any vehicle that is OEM, it'll have it in the indicator light system. So on this particular one, this is a 2007 and new with just a filtration system. You've got some new lights. You've got the new DPF lamp. Normally it's off. When it comes on, you need a regeneration, whether you increase the duty cycle or do some stationary regeneration. The other light that will come on is something called the new HEST, or high exhaust system temperature lamp. This is not on all 2007 trucks because it's not as necessary, but when the filter is going through a regeneration, it will raise the exhaust temperatures. And sometimes those exhaust temperatures can get to the point where it's too high. Your check engine lamps, whether it's yellow or red, are common for vehicles right now. They just happen to have another function when you have a DPF installed. They will tell you whether or not the filter, they'll come on if the filter is having problems. On the 2010 and newer trucks, you have one additional one. You'll have the HEST and you'll have the DPF lamp, and the check engine lights are the same, but you will also have something called a diesel exhaust fluid lamp, which is the idea that there is a monitoring system associated with the DEF tanks, which will tell you when the tank is getting, empty. The newer ones actually will tell you whether or not the DEF fluid is actually of a high enough quality to function properly. So that could be a bad deal if you have old DEF and it doesn't have the right concentration of urea to actually work. Do not ignore these dash lights, right? Do not ignore the dash lights. They are your savior when it comes to trying to take care of these filtration systems. Maintain your original duty cycle as much as possible. The filtration system was designed to work with a particular duty cycle. If it's an OEM, you don't have to deal with that as much, but if you have a retrofit, you really seriously need to maintain as much as possible the duty cycle. Idling is a problem for all diesel particulate filters because it's always going to be a low temperature operation, which will have a tendency to produce more soot than the engine filtration system can remove. And then make sure you properly maintain the ash being removed from these filters. Keep a regular schedule for that to happen. And remember that if you're in dusty environments, you're going to need to do it more often than non-dusty environments. And finally, if you track the regeneration or cleaning frequency, you're going to be one leg up on understanding when the filter actually needs to have maintenance performed. We do have a maintenance handbook. This is the older version. We do have a newer one as well. You can download this from our website in a PDF format. And here's the maintenance summary. So we've got OEM configuration, filter maintenance. Hopefully you got as much out of that as you possibly could. We do need to talk a little bit about failures, however, because these filters, even if you're watching, even if you're taking care of them, they can fail. Now, these failures happen when they get plugged or damaged, when there's excessive emissions from the engine, when there's wet fouling, regeneration failures, all of these are caused for a filter failure itself. But generally speaking, improper engine maintenance is what we find is the most common issue when a filter fails. Wet fouling is simply put having too much liquid deposited on the filter itself. That could be from excessive engine oil, from severe overfueling where raw gas is just shot onto the filter. It'll happen whenever a turbocharger blows, whenever there's an internal engine coolant leak, and it can possibly lead to a runaway regeneration. Here's a couple of examples of oil deposit on cores. You can actually see the wet liquidy material on the one on the right. That core both of these might be salvageable if they're treated properly, but generally speaking, once you get that much oil deposited on these, there's too much hydrocarbon to take care of these, and the core has to be replaced. Here's something that happens when the filter core gets too plugged and it's not taken care of. This was a runaway regeneration where there was so much soot deposited or raw hydrocarbon, maybe it was in a liquid form, in this filtration system, that when it actually started to get to the point where it was heated up because of the plugging, it ignited and burned through the core. One thing you should know about this is even though these filters are built to contain the heat and the temperature associated with them, this device, when this was happening, was probably so hot that the core itself was white hot. Dangerous, dangerous situation. Regeneration failures can often be, well, they sometimes can be the fault of the operator, but oftentimes they can be caused by the fault of the device. So for passive regeneration, if you change the duty cycle, a passive regeneration system for a retrofit absolutely needs to have a specific temperature in order to regenerate. It could be that you have a defective catalyst. Maybe you got a tank of gas that has too much sulfur in it and you just poison the catalyst. I've seen that happen three times with people who went down to south of the border and picked up some fuel from Mexico, where even though they do have sulfur content limitations, they don't monitor as closely as we do. So it's entirely possible to purchase high sulfur diesel across the border. For active regeneration, it's typically going to be something wrong with the actual regeneration parameter. So there's an electrical problem, so the heating element doesn't heat up. There's a fuel dosing issue, maybe a component like a glow plug or something doesn't function properly. But one of the things that can happen that is operator related is something called interrupted regeneration. This is fairly common for operators to not want to wait around for a regeneration to happen. The system says they need it, they start it, and they allow it to go only so long as they need to finish their job. The problem with that is that it will ultimately cause the filter to plug up before it should, because their interrupted regeneration has only burnt off a section of the filter media itself, and it winds up plugging beyond that. All right, well, if you have a filter failure, I'm going to give you a little bit of help on who to contact. First of all, the manufacturer, the installer, they're the ones that you're going to want to deal with first, because they know that device and the installation better than anybody else. If you contact the installer and they can't help, contact the manufacturer. If you have an OEM, obviously go to a dealership. That's going to be your first line. But if those avenues don't work for you, if you're not getting redress for the problems you're having with the filtration system, then we do have a call line that you can talk to somebody or at least file a complaint. There is a form that needs to be filled out, and it is an application. I hate to say it's fairly long, but what we're trying to do is, if you give us enough information, we're going to be able to do some research and find out, exactly what the problem is. So we need the information. Here's the webpage, the Emission Control Strategy Installation and Maintenance, and there is a link for resolving DPF issues. So it's right there on the page for you to link. Let's talk periodic smoke inspection program briefly, because this is entirely related and can be related to the filtration system working properly. This is a requirement, a legal requirement that has been in place since 1998 on heavy-duty diesel vehicles operating on California roads. Essentially, it applies to you if you have 2 or more diesel vehicles that are greater than 6,000 pounds with an engine model year of older than 4 years. If that is you, then you're required to do this test every year, every calendar year. Now, somebody earlier was mentioning opacity limits of 40%, 55%, and I kind of was him-hawing on that because those were the old opacity limits for this test. They have been lowered because the advent of filtration technology actually makes those levels not applicable anymore. When we opened up the regulation to change those levels, we also included some additional smoke tester training requirements and the ability to do a voluntary submittal in lieu of the testing strip or doing the testing yourself. But one of the biggest things we did is we changed the opacity levels. So here are the new opacity levels associated with this particular test. If you have a diesel particulate filter on the truck, your new opacity level is no more than 5% opacity. That is very low compared to what it was. Now, there are some engines that will not have filters on them. These would be low use engines, and obviously some of the harbor craft that we were talking about earlier, off-road, may not have filtration systems. They will have higher opacity limits because of that are allowed. And some engines are really big and have trouble controlling soot anyway, so they will also have some higher limits. As far as who does the test and what kind of training they have to have, if you want to do the test yourself, that's perfectly legal. The only thing I would say is you have to, or maybe you have an employee that wants to do it, what I'd say is you or the employee has to go through a training class, and we have an online training course. It's called MS 529. It is available on our registration system, and it was about a hour and a half to 2 hour training class where you go through some videos and you answer some questions. And once you get done, as long as you've answered enough correctly, you will get a certification and then a tester number emailed to you. That's if you're doing it yourself or having an employee do it. There are people out there that you can hire to do this test. If you're hiring somebody, in order for them to legally do it, they will have had to have gone to a training class offered by one of the community colleges in the state of California that has a diesel training program. These are part of the CDET campus system. And there are 8 of them throughout California. We've got 1 in Sacramento, 1 down in Stockton, 2 in the Bay Area, 2 in Los Angeles area, and 2 more in the San Diego area. So 1-day training course, and it's good for 4 years. So if you decide to hire somebody, make sure they have their certificate, because if they don't, it's an invalid test. If their certificate is older than 4 years, it's an invalid test. For keeping records, we require that you hold on to any of these records for a minimum of 2 years. There is no reporting system associated with this. We just want you to have them and present them to us if we audit your fleets. There is another choice for doing this test though. If you have a newer truck, anything that has something called onboard diagnostics or OBD, for heavy duty diesel engines, that would be a 2013 model year engine or newer. These devices have a way where you can connect a little monitoring device to a dongle that's underneath the steering column, and you can download information from the computer that runs the engine. There is a reporting system where you can submit the file that you're able to download, and that will constitute your PSIP test whenever you do this. So you don't have to do both. There are some future things that are happening right now. We are looking at remote telematics, which means we're looking at devices that we can place on off-ramps and on-ramps or in various road situations where they can monitor the exhaust coming from vehicles as they pass by and make a instantaneous determination as to whether a vehicle is passing or failing the smog. We also are working right now with the Bureau of Automotive Repair on a heavy-duty I&M program. I&M stands for inspection and maintenance, and that is essentially the smog test that you currently go through with your regular vehicles, except we're going to extend that to heavy-duty diesel trucks. I expect that will come about somewhere. It says 2023. That's our goal. That could happen. I think it's probably going to be 2024 or 2025, but we'll see how it works. All right, we're at the end of the information today. Hopefully I've given you guys enough information. I've talked to you about the verification and aftermarket parts programs associated with filtration, how these things work, you know, the wall flow design, regeneration. If you're in the market for one, how to pick the right filter, knowing the family name, the duty cycle, and then almost as important as all the rest combined, how you take care of these things once you have one. They're just going to become more prevalent, so you need to understand that that is going to be the deal. The required maintenance is going to be the deal as we go forward. With that, I'll back it up and show this again. Katie, did we have any questions at all?
No, we did have one comment. The Johnson Matthey CRT term is continuously regenerating technology.
Ah, good. I knew it. See, I'm glad somebody was there because I knew that. Yeah, tip of my tongue. There's always somebody that knows this stuff.
Yeah.
Okay. I'm going to put, I don't have an actual handout for this. What I'm going to do is put up a slide print that I created. Let's do this one. And it will upload, and that is a copy of the slides here. As soon as that's there, anybody can download it. What I'm also going to do is put up this and put down 10 minutes. And if anybody has any questions, we'll stick around for the next 10 minutes and hopefully be able to answer them for you. At the end of 10 minutes, I'll shut the webinar down. Well, that's the end of the 10 minutes. Katie, did we have any additional questions?
No additional questions. Just a reminder to anyone that would like the handout. The handout is actually under the handout section of the control panel now, so you can download that. And then if you would like to request a copy of the recording for today, just send us an email. It's hard to track people if you just put it in the question box. So just send Randy or I an email and request that, and we can send it over to you.
Okay, well, they won't have much time to download because it's time to stop the webinar. I'm going to close it up and hopefully everybody has a good afternoon. I will talk to you later.